Ladies and gentlemen, students and studentesses, thank you so much for joining us once more right here at Raetse Education. Remember the website www.raetse.co.za. All right, getting straight into it. This is chemistry, specifically organic chemistry for grade 12s. Now, this is presented and, of course, researched by the ever so knowledgeable Naledi Sello. Thank you so much for being with us, ladies and gents. I hope that you know that we at Raetse, we care about you. That's why we even have an in-house psychologist to help you out with whatever strains might be locking you down. Get it? Lockdown. Don't let it get you down, man. Keep on studying. Make sure that you're getting a step closer to that wonderful graduation day.
Hey guys, Naledi here, and I'll be taking you guys through organic chemistry today. This is a very interesting topic, but first of all, let us look at what exactly chemistry is. Guys, I love chemistry. I love chemistry because I live chemistry. Literally, I live chemistry. Why do I say that? Well, chemistry is in my community, chemistry is in my health, chemistry is in my environment, and chemistry is in my medicine. Chemistry is in my industry, and chemistry is in science. Chemistry is in the teachings, and chemistry is research. Lastly, chemistry is you. You and me are both chemistry. In everyday life, we literally live chemistry. From getting out of bed in the morning until going to bed at night. That is literally chemistry. What exactly am I talking about? Let us look at what exactly chemistry is. Chemistry is the scientific study of the basic characteristics of substances and the ways in which they react or combine. What am I saying? I'm saying those substances are the food that you eat, the water you drink, the batteries you put in your phone, literally everything, the air that you breathe. That is what I'm talking about. So the characteristics in those substances and the ways in which they react or combine, that is exactly what chemistry is. Guys, when doing chemistry, we need to know and understand what exactly we are doing. Before we do any question, we need to study our definitions. Please, guys, let us study our definitions. Here are some important words, or rather definitions, that we are going to use today. Number one, I've got a solid here. What is a solid? A solid is something hard or rigid. I used ice as my example because ice is solid, ice is hard, ice is rigid. So that is a solid. Number two, we've got liquid here. Liquid is the opposite of solid. Liquid is a substance that flows freely. I used water as my example here because water flows freely and therefore it is liquid. Number three, I've got gas. What is a gas? A gas is a substance that can expand freely. It expands, not flows. A liquid flows, but a gas expands. For example, I used air. Air is a gas. Air expands freely. Number four, I've got atoms. What are atoms? Atoms are extremely small particles in a chemical substance. For example, minerals of a rock, those are atoms. Those tiny little minerals in a rock, those are what atoms are. you will hardly see an atom because atoms are extremely, extremely small particles. Number 5, I've got electrons. Electrons are the smallest of particles that make up an atom. Guys, you can imagine how small an electron is because I said atoms are extremely small particles. Now you can imagine how small an electron is because it makes up an atom. But let's remember that an electron carries a negative charge. And then we've got our protons. Our protons are equal to our electrons, but they carry a positive charge. They also make up an atom. And then number 7, we've got our neutrons. A neutron is also small particles that also make up an atom, but they carry no charge at all. Let us get to the business. Organic chemistry. Guys, I know you guys have never done organic chemistry. It can be a complicated but very fun topic. If you really put your time to it, you'll really enjoy it. I know how difficult it is for you guys right now because it's locked down. You guys are not attending class. You've never really had a teacher to explain to you what this organic chemistry is, because I know you've never done it in grade 10 or 11. And now you have to start doing organic chemistry, and you've never done this in your life. And also you don't have a teacher there to help you. But you've got raetse.co.za to help you guys. Let us look at what organic chemistry is. Organic chemistry is the branch of chemistry that deals with organic molecules. Remember, we defined what chemistry is? Chemistry is the characteristics of a substance when they react or combine. That is chemistry. So this is the branch of that chemistry that deals with organic molecules. Guys, let's not confuse organic compounds with organic or naturally produced food. It is totally different. Organic compounds are produced in a lab. They are produced by our scientists. So, you guys are probably confused now because I'm talking about organic compounds and I'm also talking about organic molecules. Let us look at what exactly is compounds and what exactly is molecules. Compounds are made of 2 or more elements, and molecules are made of 1 element. What is this element? Elements are your hydrogens, your nitrogens, your oxygens, and so on. Those are elements. So a compound is made of 2 or more elements, meaning it is not just made by 1 hydrogen, it is made by different. It can be an hydrogen and an oxygen and a nitrogen. That is a compound. But a molecule is made of 1 element, meaning it only consists of just the oxygen or just the hydrogen. That is what I mean. Here I have an example for you guys. I used water. I said water is a compound. Why? So I used water because water is H2O, and water is a compound because it contains of more than 1 element. We've got our hydrogen element and our oxygen element. Therefore, this is a compound because it contains of more than 1 element. Example 2, I used hydrogen gas, which is H2. I said it's a molecule. Why? Because it contains of 1 element, which is our hydrogen element. So guys, here I've got this in red and bold that all compounds are molecules, but not all molecules are compounds. What is an organic molecule? Remember, we checked what molecules are. Now we also said organic compounds, we must not confuse them with our organic or naturally produced food. These are all produced in a lab. So a molecule that contains carbon atoms is an organic molecule. It needs to contain carbon atoms, at least one carbon atom, generally bonded to other carbon atoms as well as hydrogen atoms. So all organic molecules or all organic compounds contain at least one carbon atom. If there's no carbon atom, it is not an organic molecule. Let's keep that in mind. So they are bonded to other carbon atoms and as well as hydrogen atoms. Here are organic molecular structures. Carbon is a very, very, very special element. It is very special and unique. Here are some special properties of a carbon element. Carbon has a number of unique properties which influence how it behaves and how it bonds with other atoms. Number one, each carbon atom can form a maximum of 4 bonds with other atoms. Because of the number of bonds that carbon can form with other atoms, organic compounds can be very complex. So what I mean by carbon atom can form a maximum of 4 bonds. Look at this picture of a carbon element. On B, we've got that carbon element and it's got 4 dots around it. Those we call a Lewis dot representation. I think you've done this in grade 11. So this is how it's going to bond with other elements, but we don't use those dots. We're going to use branches. Not branches, we'll use stripes. I don't know what it's called, but they bond when there's those stripes together with the carbon element. So carbon can form bonds with other carbon atoms to form single, double, or triple covalent bonds. Here at the bottom, I think you can see we've got here by the catenation, we've got A, B, and C. A is a single bond, B is a double, and C is a triple. You can just look at B between the second carbon element and the third carbon element, there's 2 stripes. That is a double bond. As well as C, between the second and third carbon, there is 3 stripes, which is a triple bond. And then here we've got carbon can also form bonds with other atoms like hydrogen, oxygen, nitrogen, and the halogens. Carbon can bond to form straight chain, branched, and cyclic molecules. So here at the bottom, you'll see what I'm talking about. So we've got, because of this, long chain structures can form. This is known as catenation, the bonding of atoms of the same element into longer chains. These chains can either be unbranched or branched and can contain single carbon-carbon bonds only or double and triple carbon-carbon bonds as well. So here on A, B, and C, these are all unbranched because they're all straight. And then here at the bottom, we've got branched because you see it looks like it's a branch. We've got more carbon atoms at the top and then we've got more at the bottom and then we've got, that is what branched and unbranched means. Then you can just go through this. The notes will be on the website, Raetse website. So there's more definitions we need to know. We need to know our covalent bond or molecular bond. A covalent bond can also be called a molecular bond. So this is when our electrons, when an atom shares electrons. Do you understand? If we've got 2 atoms and then they have to share electrons, that is what a covalent bond means. So on number 9, we've got our non-polar covalent bonds. those are when our electrons are almost or equally shared. That is between 0 to 0.5. That's our electronegativity if it's between that. You need to go check your periodic table to do this. But here on the notes, you'll also see what I'm talking about. And then for our polar covalent bond, we've got our non-metals, which is our electrons are unequally shared. That is between 0.5 to 1.7. That is our electronegativity between the two atoms. And then we've got ionic, that is our metals and our non-metals, which is from 1.7 to 4. That is the electronegativity. So on the periodic table, most the bonds that carbon forms with other atoms are covalent. Think, for example, of a carbon-carbon bond. The difference in electronegativity between the two atoms is 0. Why do I say it's 0? Because carbon and carbon have the same electronegativity, and therefore it will give us a 0, because the protons and the electrons for the carbon is equal, and it will end up giving us a 0. And then in this, so this is a pure covalent bond. You will check there on your definitions. And then in the case of a carbon and a hydrogen bond, the difference in electronegativity between them is the carbon is 2.5 and hydrogen is 2.7. So difference is U minus. Now we're going back to our mathematics. And so the electronegativity between them is so small that the carbon and hydrogen bonds are almost purely covalent. So the answer that we get here is the 2.5 minus the 2.2 gives us around 0.3, and that is between 0 and 0.5. It means it's non-polar because they almost equally share their electrons. So it is a non-polar covalent bond. And then we come to the sources of carbon. This you can just go through them on your notes when you go to the website. I just did this for you guys so that you're able to see what exactly I'm talking about, because sources of carbon, this is what happens. We've got our carbon dioxide, our water, and then it gives us our photosynthesis. So you can just go through this on the website because you'll get these notes provided for you guys. And then here we get to representing organic molecules. There are a number of ways to represent organic compounds. It is useful to know all of these so that you can recognize a molecule regardless of how it is shown. So I'm going to show you guys a few ways of representing an organic molecule. When writing or drawing or doing anything in organic compounds, this is the kind of steps that you'll be taking. The beginning of a compound name, which is the prefix, comes from the number of carbons in the longest chain. So if you've got one carbon atom, it means the name of that particular compound will start with meth. If you've got two atoms, it will be called an F. If it got 3 carbon atoms, it will be called prop, and so on. This is how you'll see it. And then the end of compound name, that is the suffix, comes from the functional group. For example, it will be your alkanes or your alkenes. So if it's an alkane, it has a suffix of ane at the back. So you've got your prefix, which is meth, and then your suffix will be ane. So it's going to be methane if you've got one carbon atom, and then this has only one stripe, that is one bond to the hydrogens, so it will be called a methane. Yes. So here we've got the name of the group, which is alkane. The functional group will be 2 carbons. You see now we've got 2 carbons, and if it's 2 carbons, it's an F, and then ane at the back because it's an alkane. So it's going to be ethane. And then this is the structural formula of how you represent it. And this is your alkene, which is your alkene has two stripes here because it's an alkene. It doesn't have one stripe, it's not an alkane. And then when you have two carbons, it means it's an eth, so it's called ethene. And this is how you represent it in your structural formula. And then the ine as well, it's the same, which is our alkyne. And then we have our haloalkanes or alkyl halides, which is, these are all our alkyl halides, our haloalkanes, which is your chlorines, your bromines. You need to know those are on your periodic tables. So, but I've put them down here for you guys. So if you've got that, now this is an example of the name, which is chloromethane. The reason why we say chloromethane is because chloro means we use the chlorine, and then meth means it contains one carbon element, and then we've got ane. It means there's no double bond or triple bond, it's a single bond. So that's why it is a chloromethane, right? And then we've got our alcohols. Our alcohols here, it is alcohols, you always add an OH at the end. So, and then when you call it or when you say it, you say nol at the end. Something nol. Anol actually, yeah. So here we've got our methanol. Why do we say methanol? Because it contains of one carbon, that is a meth, and then anol, it's because it's a alcohol. And the way you write it, you say methanol. But the way you represent it on your structural formula, it has an OH, it is one carbon, one C, and then it's your HHH. All your hydrogens bond with your carbon, and then the other one bonds with the OH. That means it is a alcohol. And then we've got our carboxylic acid. Our carboxylic acid, we say it's got Q. Why do we say Q? It's got Q at the end. It's a double at the O, and then the other O is OH, like the alcohol. So that our carbon atom will be bonding with two, and then it's going to two stripes, which is our oxygen, and then it's going to bond at the bottom with our OH as if it's an alcohol. That's how we'll know it is a carboxylic acid. So we add our Q, which is our C double OH, our carbon, two oxygens and a hydrogen. That is a carboxylic acid. So the reason why we said meth, it's because it contains of one carbon element, and then it has Q at the end. So it's a methanoic acid. That's it. So this is the structural formula. This is just an explanation. The structural formula of an organic compound shows every bond between every atom in the molecule. Each bond is represented by a line. This is what I've been explaining. So the structural formula of 2-methyl propane and butane are shown below. But I'm still going to teach you guys how we say these two what. But let me just explain. So guys, we've had a look at how we actually do a structural formula, our examples, our functional groups, and the name of groups. Now I'm just going to take you guys through on how we actually do this structural formula. So I've got notes here for you, as you guys can see. The structural formula of an organic compound shows every bond between every atom in the molecule. Each bond is represented by a line. That's what I've been explaining. So the structural formula of 2-methyl propane and butane are shown below. So I'm just going to show you guys why exactly I call this compound 2-methyl propane, and I'm going to teach you how to do it as well. Here on A, we've got 2-methyl propane. The reason why we call it 2-methyl propane is because At the top there we've got one carbon atom, and remember when we said when you have one carbon atom, it is called a meth. The prefix is meth, and at the end it's ane. So here at the bottom we've got 3 carbon atoms, and those 3 carbon atoms, we are going to call it our prop because it's 3. So remember that when we've got 3 carbon atoms, it is called a prop. So this thing is called a methyl propane. So the reason why we said 2 is because that one at the top there is bonded to the second carbon at the bottom. So that's why we've got 2 methyl propane. It's a propane because it doesn't have any double or triple bonds. It is only a single bond, therefore it's an alkane. So it's a 2-methyl propane compound. Let's keep that in mind. And then here on B we've got your butane. The reason why we say it's a butane is because it's got 4 carbon atoms, and 4 carbon atoms means it's a but, and then our suffix is ane because it's an alkane. It doesn't have double or triple bonds. It's not an alkane, it's not an alkene, it's an alkane. So yeah, sorry, it's an alkane, not an alkene or an alkyne. So this is a butane. So on our semi-structural formula, we say that it is possible to understand the structure of an organic molecule without writing out the carbon-hydrogen bonds. So you don't really have to write down your carbon-hydrogen bonds. So this is called a semi-structural formula. This way of writing a structure is called a semi-structural formula, and it is shown below. Here we've got a semi-structural formula for 2-methyl propane. You see, we don't have all our hydrogens written, we just have them written in numbers. So here we've got 1C plus 3 H3s, and then it's a bond onto the CH, onto the CH3, onto the CH3. So this is called a semi-structural formula. It doesn't really differ that much from your structural formula, but it's just that this one just doesn't have everything written here. It's just written in numbers. And then just remember that a substituent is an atom or group of atoms that replaces a hydrogen atom on the main chain of an organic molecule. Therefore, a branched group is a substituent. So this 2-methyl propane is a substituent because it's a chain of an organic molecule. It is chained, it is branched. It's not a chained, it's a branched group. So it is called a substituent. So a condensed structural formula represents a molecule without showing any bonds between atoms at all. So you don't really show those bonds between the atoms. You just basically give the formula. So it is called a condensed structural formula. So it is written here at the bottom. It is your CH3CH, CH3, CH3. The reason why we have this bracket is because the one that is shown in brackets is after the carbon atom to which they are bonded. So the one that is branched and it's bonding to that other carbon, that's why we give a bracket. You'll have to go through your notes, guys. And then just note that the figure above on example B, the 2 CH2 groups can be abbreviated to CH2. So that closed bracket for CH2 and the 2 outside the bracket. So you can compare these condensed structural representations with the structural and semi-structural representations to check if your answer is correct. We get to our molecular formula. The molecular formula of a compound shows how many atoms of each type are in a molecule. The number of each atom is written as a subscript after the atomic symbol. The molecular formula of 2-methylpropane is C4H10. Why do we say it's C4H10? let us look at this. Let us look at 2-methyl propane here on our structural formula. We've got how many C's here? Let's count our carbons. We've got 1, 2, 3, 4 carbons. We've got 4 carbons, hence it's written C4. And let's check our hydrogens. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We've got 10 hydrogens. So our molecular formula for 2-methyl propane is C4H10. But note that also for butane, we also have C4H10. So the molecular formula gives no structural information about the compound. So two compounds can have the same molecular formula, but we can still have no information about that compound. So for our functional groups, a functional group is a specific group of atoms and the bonds between them that are responsible for the characteristic chemical reactions of those molecules. So in one group of organic compounds, that is called the hydrocarbons, the single, double, and triple bonds between carbon atoms give rise to the alkanes, alkenes, and alkynes. Let's remember that. So in other group of organic compounds, remember we also have our alcohols. An oxygen and a hydrogen atom are bonded onto each other to form the functional group. In other words, the alcohol has an OH in it, which is our oxygen hydrogen. So let us look at the saturated and unsaturated structures. What is a saturated compound? A saturated compound has no double or triple bond. So which one has no double or triple bond? For example, we have single bonds only. What has a single bond? We can use our alkane. Our alkane has a single bond. Therefore, it is called a saturated compound because it's got only a single bond between the atoms. And then an unsaturated compound contains double or triple bonds between the atoms. So those are our alkenes and our alkynes because they've got double or triple bonds between the atoms. Also, we've got our hydrocarbons. So an organic molecule which contains only carbons and hydrogen atoms with no other functional groups besides single, double, triple carbon-carbon bonds. So we'll go through this on our notes. You can get the notes from the website on www.raetse.co.za. So here we're just talking about our alkanes, our alkenes, and our alkynes, and the classifications of the aliphatic hydrocarbons. So you'll just go through this on the notes. And then here I'm just gonna use this one alkane as an example. The alkanes are hydrocarbons that only contain single covalent bonds between their carbon atoms. This means that they are saturated compounds and are quite unreactive. They are unreactive because the bonds between the atoms is very weak, and that makes them unreactive. It is a single bond. So for your alkenes and your alkynes, those are highly reactive because the bonds between the atoms is stronger because it's double and it's also triple. So our alkanes are not reactive, and this is how it goes. You can just also read through this so that you understand. So this is a simple alkane. It has only one carbon atom and it is called a methane. The molecule is shown here below and the molecular formula is CH4. So the second alkane in the series has 2 carbon atoms and it is called a ethane. And then the third one is a propane because it's got 3 carbon atoms. And then you can see that when you look at the molecular formula for each of the following alkanes, you notice that the pattern developing for each carbon atom that is added to the molecule, 2 hydrogen atoms are added. In other words, each molecule differs from the one before it by C H2. So this is called a homologous series. So a homologous series is a series of compounds with the same general formula. All molecules in the series will contain the same functional groups. Look at the summary of the relative reactivity and the homologous series that occur in hydrocarbons, and it is given in the table here below. So you'll just go through this on your notes. It's going to be provided on your notes. And then for the alkenes as well, we've got the same thing. Here's the general formula. And then we've got the same thing for your alkynes and your alcohols, and that's your general formula there. And then you can go through this. That's your primary alcohols, your secondary alcohols, and your tertiary alcohols. And then we've got our alkyl halides, which is your chlorines, your bromines. You'll also go through this. The what's this? The general formula is also provided for you, and then you'll also look at your carboxylic acids. Yeah, that's it for now. We'll go through more of this. We'll still have your IUPAC names. So when we get to your IUPAC names, that's when we are going to get deeper into this, and then I'm going to explain your ketones, your aldehydes. There's still more into this though. So this was just the beginning of organic chemistry, so that you understand and know what you're doing. You have a quiz provided for you on the website, so that you can work from that and test and see whether you're able to do this work on your own. Thank you very much for watching, guys.